Hello everyone, welcome to the second episode of SMOPS commonly tested questions. So I'm Mr. Zhang from Poker Education. So in this video, we will discuss two questions about the divisibility of numbers. So let's take a look at the first question. It's from SMOPS 2018. So we are given this number, it says that it's a multiple of 11. We need to find the smallest value of n. So if a number is divisible by 11, we can divide all the digits into two groups. So each time we skip one digit in between. So from here, 2, 1, 2, 1, then 2, 1, 2, 1. After the last digit 1, we have 9 and 5. This is the first group. For the second group, we have 0, 8, 0, 8, then 0, 8, 0, 8, and another 8. So let's work out the sum. Now, for the first group, so the 2 and 1, it comes from the number 2018. There are n groups of 2018, so there are n groups of 2 plus 1. So 2 plus 1 times n. Now, after the last group of 2 and 1, we have another two digits, the 9 and 5. So we add them in, plus 9 plus 5. Total equals to 3n plus 14. Then we check for the second group, that 0 and 8 is also from 2018. So 0 plus 8 times n. Now, after the last group of 0 and 8, there's another digit 8, so we add it in, plus 8. The sum is 8n plus 8. And now we check the difference. Difference between them is a multiple of 11. We use 8n plus 8 minus 3n plus 14. Okay, so 8n minus 3n equals to 5n. Plus 8 minus 14, the same as minus 6. So we check the different cases. First, we can let 5n minus 6 equals to 11. 5n is 17. Right? N is not a whole number. So this one is wrong. Then we check the next multiple of 11, which is 22. So 5n minus 6 equals to 22. 5n is 26. 28 is not divisible by 5, so this is wrong. Next case, 5n minus 6 equals to 33. So 5n is 39. N is not a whole number. Then after that, we have 5n minus 6 equals to 11 times 4. So equals to 44. 5n equals to 50. So n is 10. Okay. So for this question, the answer is 10. Right, let's move on to the next question. This is from SMOPS 2021. So we're given this number, they tell us the factorization. So it contains factor of 2, 3, 7, and 11. How many factors of this number is divisible by 2 or 7, but not by both? So we have two cases. Case 1 is the number that's divisible by 2, but not divisible by 7. If a number is divisible by 2 but not divisible by 7, so let's check. For factor of 2, so it must contain factor of 2 in order to be divisible by 2. In this case, it can contain 1 factor of 2, or it contain 2, or it can contain 3, 4, or 5. So there are 5 ways to choose the factor of 2. Either you choose 1, 2, 3, or 5, 4, or 5. 5 ways. Okay, then for factor of 3, there are 3 ways. So either not choosing factor of 3. 3 to the power 0 is just 1. Or we can choose 1, or we can choose 2. So there's 3 ways in total. There's 2 plus 1. Now, this is not divisible by 7, so it does not contain factor of 7. So for factor of 7, there's only one way. We choose 0 of them. 7 to the power 0, that's just 1. So there's one way for factor of 7. Factor of 11, there are 2 ways of choosing it. Either choose 0 or choose 1. So that's 1 plus 1, 2 ways. So now we times everything together. It's equals to 5 times 3 times 1 times 2 equals to 30. That's for case 1. Case 2 is that the number is divisible by 7, but it's not divisible by 2. So if it's not divisible by 2, means for factor of 2, it contains 0 of them. To the power 0, there's one way. For factor of 3, this is the same. There are 3 ways. It's either 0, 1, or 2. Times 2 plus 1. Now, the number is divisible by 7, so it must contain factor of 7. So for factor of 7, there's either 1, 2, or 3. It's 3 ways. Factor of 11, there are 2 ways. Either choose 0 or choose 1. So times 1 plus 1. This equals to 1 times 3 times 3 times 2 equals to 18. So altogether, we have 30 plus 18 equals to 48. So there are 48 different factors in total. Thank you for watching. So I'll see you in the next video.